had a lot of reactions in the US already. We are delighted to present this report today in Europe. And we have a very interesting panel today with Rob Gramlich, Grid Strategies, Oliver Koch from DG Energy, John from Supernode, John Fitzgerald, Michael Jesberger, the CTO of Transnet BW, and Giles Dixon, the CEO of Wind Europe. I'm Susanne Nies, I'm the board chair of Current and working for Smart Wires, and Jenny.
Hi, everybody. Thanks for joining. I'm Jenny Irwin. I'm the board chair of Watt, also working for Smart Wires.
Excellent. So let's have the next slide to give a little bit more detail on who the speakers are. So Jenny, you want to start with the American colleagues?
Sure, absolutely. So today, Jay Casberry will be presenting the Brattle study, as Suzanne mentioned. Jay is Vice President of Grid Strategies and has been working with the Watt Coalition for about the past year or so. Jay has over 40 years of experience in transmission planning, engineering, and management, worked for a variety of stakeholders across the spectrum, including Southwestern Power Pool, which is where the study was focused, and the Department of Energy, and also Illinois Power. And then Rob Gramlich. Rob is CEO of Grid Strategies, and he's been working with the Watt Coalition for the past 4 years, and he serves as Watt's executive director. Rob has significant experience in the policy realm and has worked for utilities, ISOs, the wind industry, and also FERC, the federal regulator for electric transmission in the US. And Rob will be providing a perspective on what's happening right now between Congress, Biden, and FERC, and what that means from a transatlantic collaboration perspective.
Thanks a lot. And the European team is Oliver Koch from DG Energy. He is working for several years now in DG Energy and was working on the internal market as much as on new technology solutions, on network codes, on the energy community, and represents the Commission today. John Fitzgerald is one of the co-founders of Current, and he's the CEO of Supernode. Supernode develops superconductors that is a clear needed ingredient for a future with 100% renewables that we all want to see. And then we have Michael Jesberger, who is a very convinced European. Michael is leading the work in Brussels on transmission and distribution interface. He worked before in Siemens, he worked in TenneT, and today he's the CTO of Transnet BW in Germany, which is one of the 4 TSOs located in the south and known for its innovative approach. And finally, Giles Dixon, CEO of Wind Europe, that is the face, I would say, of one of the 2 major parts of the renewables, the wind and the solar. He's Mr. Wind in Europe, known to the heads of state and government, was previously working in Alstom as well a long time ago, and is a very respected player in Brussels and Europe and globally. So thanks to all our speakers to be here today. Let's move to the next slide, please. So I also want to mention that Current, like the sister structure in the US, has just commissioned a report to Consentech. And this report will look into the combined benefits of grid enhancing technologies. What is the benefit of intelligent power grid design tools? We want to present this study in the infrastructure forum. That's most probably happening in October later this year. Next slide, please. So grid enhancing technologies, what is this? Grid enhancing technologies are hardware, software, associated protocols. They encompass modular power flow control like Smart Valve or Smart Wires is offering dynamic line rating, which is a couple of different dynamic line rating technologies, superconductors that I already mentioned, innovative sensors, topology control. You find all this also on not only the website of Current, but also of ENSOE and the Technopedia that we have been exchanging on with ENSOE. Next slide, please. And why is it so important to focus on grid enhancing technologies? I would like to point you here to the very recently published IEA Net Zero Roadmap. And many people, me included, have been saying, that's great that IEA is really saying now fossil fuels need to be phased out by 2030 for coal, and that they recognize the need for a very ambitious roadmap. My own country, Germany, now wants 65% of emission reductions by 2030 after the federal court has voted down the existing climate legislation stating it wasn't fit for purpose entirely. So here you see in this IEA Net Zero Roadmap that electricity becomes the core of the energy system. And if we say electricity and as it's network bound, it means networks have to be fit for purpose too. Investing 50 billion euro in Europe year by year to 2030 is certainly not very sustainable unless you combine it with the optimization of existing grids, of reinforced grids, and in the future with future grids as well. So the next slide, please. It's central also because we need to have renewables. Grid enhancing technologies mean that more renewables can get into the system. That's precisely the narrative that we will hear from the Brattle report, Unlocking the Queue. Next slide, please. And electrification, as I said already, we see here the overview on what it means. Electrification will encompass all sectors in the future, be it mobility, be it heating, cooling, and transport. There will be a system of systems that will be digital, that will be innovative if it will be competitive in the end. Next slide, please. Yeah, Karen, I already mentioned our association. We are a group of small innovative technology providers that are there to unleash the potential of the existing grids. We have published a policy paper that's called Climate Proof Europe's Power Grid, and we are respected contributors to the European Florence Forum and to other forums, and we make our voice heard on new legislation like 10E. Next slide. And hand over to Jenny now on WATT.
Thanks, Suzanne. As Suzanne mentioned, WATT and Current are sister organizations. So WATT stands for Working for Advanced Transmission Technologies, and we're focused on policy and advocacy in the US market. We've been around since 2017, and our ultimate aim is to accelerate the clean energy transition and lower energy costs for consumers. We do that by advocating at the federal and state levels. So you can see a variety of the stakeholders that we work with across the spectrum: FERC, Congress, the state public utilities commissions, ISOs and RTOs, so the market operators, utilities, developers, and plenty of others. You'll see some overlap with the current membership. We have power flow control, dynamic line rating, and topology optimization represented for technologies. And we also have grid dependent entities like EDF Renewables who want to use GETs to reduce connection timeframes or costs, or curtailment of existing assets. And so WATT today is focused on three key advocacy initiatives: the infrastructure stimulus, transmission policy reform, and the generation connection process. And we see opportunities for GETs to play a role in all of these fora. So we can go to the next slide. Thank you. So you'll hear more detail on the study in a couple of minutes. So it's done by the Brattle Group. And I wanted to give you a little bit of background on where this initiative came from. So late last year, we took a step back and evaluated what was happening on the US grid and anticipated a potential change in direction at the federal level and wanted to make sure that we were part of that discussion. And so what we saw was massive renewable demand from stakeholders across the spectrum. and hundreds of gigawatts of projects stuck in the connection queues. And while there's a significant amount of grid investment planned, these trillions of dollars are taking decades to deploy. So the question is, can we unlock the potential of today's grid to facilitate some of this transition? Next slide. And so the area we focused on, we narrowed our study region to something large enough that was representative of the broader system, but small enough that we could study it quickly and with the right level of granularity. So we focused within SPP, which is the Southwestern Power Pool. You can see SPP is sort of a big swath of the central part of the US. And we looked specifically at Kansas and Oklahoma. And so if you look at the figure on the right, Kansas and Oklahoma are in the southern part of that figure. They're where the vast majority of renewable connections are planned within SPP. And what we wanted to understand was, from a capacity and energy standpoint, what impact could GITS have on generation connection? And what would this mean in terms of dollars for consumer saving, tons of CO2, and local jobs? So next slide. So to give you a sense of scale, what does Kansas and Oklahoma look like compared to Europe? This is roughly the size of Germany in terms of land mass. And the transmission system is about the size of TenneT's system. So the implications for these study results stretch far beyond the US borders, because at the end of the story, at the end of the day, this is a story about an area of the grid where there's significant connection potential, and how do we take advantage of that? So today there's roughly 10 gigawatts of wind and solar seeking connections on within Kansas and Oklahoma. And it's not reflective of a capacity shortfall. It's just how many generators have completed the initial work to make an economic case for connection. We recognize that additional grid will need to get built to make sure all this generation can connect, and as fossil fuel facilities continue to require. But again, as I mentioned before, that investment is taking a long time. So what we wanted to explore is the impact that GITS can have in the short term. And spoiler alert, we can double the amount of generation that can connect in the next 5 years, from 2.5 to 5 gigawatts. And these are long-term solutions that can be implemented quickly. We're focused on the next 5 years because we wanted to show meaningful near-term progress. So without further ado, I'll pass things off to Jay, who is going to describe the study in great detail. So Jay, please take it away.
Thanks, Jenny, and thanks, Suzanne, and thank you for participating on this webinar. I'm going to try to fly through my slides to make sure that we have plenty of time to let the panelists discuss, as well as to get to your questions and answers. I think that's the most valuable part of any of these webinars. So thanks for joining us. Let's go forward one slide. This is the cover slide of the study that is posted, available on the internet at the Watt Coalition website. It was led, as you've heard, from the Brattle Group. Bruce Tushita and his staff deserve a lot of the credit for doing this work. I'd like to skip over the next slide if we can, although I do want to recognize the sponsors of the work. The folks at Grid Lab, EDF Renewables, as well as Duke Energy Renewables and Next Era actually contributed to this study, and we appreciate that. We've been spending a lot of time talking about this study, and it's great to share it with the folks across the pond, and we're hoping to share it at CGRE events later this year in the US, as well as hopefully CGRE in Paris next year. So stay tuned and let's keep this conversation going. So why are we doing this? The important thing is there's a tremendous amount of interest in decarbonizing the grid, and the best way to do that is with wind and solar resources at the utility scale. And to do that, we need lots of transmission, but transmission takes time, right? So that there's a significant push in the US and abroad to decarbonize the economy. And the best way we think to do that is with grid enhancing technologies in the near term. Let's go to the next slide, and I can fly through this one because I think we mentioned what the Watt Coalition is all about a little bit. But before we do, I guess, let's talk a little bit about the roadblocks. So, you know, SPP is the leader for wind integration in the US. Wind was the primary resource of energy in the Southwest Power Pool last calendar year, which is quite an accomplishment. And that's been enabled due in large part to major transmission expansion, but the grid's saturated now, and there's basically a backlog in the generation interconnection queue that's going to take years to unwind. What we wanted to do with this study was to look at this time difference, this gap in time between when these renewables could be developed and the ultimate network grid can be expanded. And we wanted to evaluate the merits of grid enhancing technologies in this study. Let's go to the next slide, please. And when we do this, we'll give a quick overview of the study. I appreciate Jenny and Suzanne talking about the Watt Coalition and the different technologies. We don't need to spend a lot of time on these, other than I want to be clear that we looked at the complementary and aggregate benefits of these technologies in this study. Advanced power flow controllers, along with dynamic line ratings, along with topology optimization, all combined to see how they would affect the plans and the ability to integrate renewables in SPP sections of Oklahoma and Kansas in 2025. Let's go to the next slide. And I want to, the reason we did focus on Kansas and Oklahoma is not only because the queues have tremendous amounts of wind primarily and a little bit of solar in the queues in those two states, but also they've been identified as areas that are constrained in the planning process. So we want to evaluate with power flow control, dynamic line ratings, and topology optimization, how these technologies can help us integrate more renewables sooner. And we want to look at the renewables that will be added in terms of capacity and energy, as well as the economic benefits and the environmental benefits in this case study. Let's go to the next slide, please, and talk a little bit about the study approach and how we did this. So we actually took 24 actual snapshots of grid operations in 2019 and 2020 and created buckets of scenarios that would capture the equivalent amount of total wind curtailment in each of those buckets. As you see, very little curtailment happens in the left bucket, but in the right buckets, there was a lot of wind curtailment. So we wanted different snapshots that actually represented an equivalent amount of curtailments across the calendar year. We modified these snapshots to reflect approved transmission expansion projects, as well as generator retirements, generator additions, as well as even customer-sponsored projects that were being implemented as a result of sponsored upgrades funded by wind developers to help them get more energy and capacity out of their wind resources above and beyond what is approved in the SPP transmission expansion plans. So we took these 24 power flow models and updated them, again, to identify the economic and environmental benefits of the combined 3 grid enhancing technologies in these snapshots. Let's go forward to the next slide, please. And what we did, so we had to modify these models. We ended up running a tremendous amount of security constrained optimal power flows. This was not a production cost simulation over time, but these were snapshots, but we wanted representative snapshots to capture what we could actually expect in 2025 based on approved plans. And we did this through a very iterative analysis where we applied one technology at a time, redispatched the wind and solar resources that are in the queue to see how many of those could actually be integrated without violating thermal and voltage criteria. So this was primarily a reliability analysis. We did include a threshold in this analysis that regarding the economic viability of new wind and solar projects, they would not be viable if there was more than a 5% curtailment. So that created a lot of iterations in these solutions. One thing that's important is to note that curtailment of these wind and solar resources occurs largely due to 2 reasons. One, transmission congestion, which grid enhancing technologies can solve. And the other issue is minimum generation constraints. You know, the minimum generation output of machines that are self-dispatch, committed into the markets. So let's go forward if we can. Give you a little bit of background of the quality of the resources in these markets. So here are the study results. In the top right table, you can see that within Kansas and Oklahoma, there's about 9.2 gigawatts of potential wind and solar projects, almost all wind, and the majority of that is in Oklahoma versus Kansas. 9.4 gigawatts of total renewable resources that are in the queues just waiting to be to move forward. So these projects have gone through the studies process, they've got signed interconnection requests, and they're just waiting. So the purpose of this study was to identify how many of those 9.4 gigawatts of wind and solar projects that are in the queue could actually be expected to be integrated reliably into the system in 2025 based on planned changes to the grid. And as you can see in the bottom left, 2.58 gigawatts of the wind and solar resources, primarily wind in Kansas, could be integrated looking at the current system and approved plans. Now, if we were to use the grid enhancing technologies, again, in sequential order and looking at the combined aggregate effects of those technologies, we would increase the total amount of renewable integration to 5.25 gigawatts in Kansas and Oklahoma. And the biggest shift was in new wind that would be integrated in Oklahoma as a result of this study. You can see that we can get 2.67 gigawatts of additional renewable resources integrated into the system using grid enhancing technologies in 2025 based on approved plans. This is tremendous. I'm an engineer. I expected to see a significant improvement and amounts of new renewables that could be integrated reliably with these technologies, but I didn't expect it to double. But what we're seeing is that the amount of integration of renewables could double using grid enhancing technologies, and the amount of wind that could be added is actually 1.5 times the amount of wind that was added in SPP in 2019. Let's move forward to the second slide. I'd like to go a little bit into the results and talk about the energy as well as the capacity. We mentioned the 2.67 gigawatts of additional wind. That equates to about 8.8 thousand gigawatt hours of energy. Most of the energy enabled as a result of GITS is due to wind injections. It's important to note that also the grid enhancing technologies lower the curtailments to existing wind on the system. This doesn't just benefit new wind that could be on the system. We made some estimates of what it would cost to place in service all these grid enhancing technologies, whether it's sensors for dynamic line ratings and software for topology optimization, as well as hardware for smart wires type power flow controller devices. And that was estimated to be about $90 million one-time cost. The annual O&M associated with that equipment is about $10 million. But if you look at the benefit side, it's tremendous. It provided a 6-month payback. We estimated that the annual production cost savings associated with freeing up this additional energy is about $175 million per year. And that's based on a really conservative $20 a megawatt hour displaced energy cost. You can also see the significant benefits in terms of jobs in the near term, as well as long term. The near term is primarily to install all the new renewables out in the field, as well as some jobs to install and enable the grid enhancing technologies. But by far, the jobs are related with the renewable resource projects. You can see local land leases, as well as tax revenues, as well as significant reductions in carbon emissions that would result from this case study in Kansas and Oklahoma. Let's go forward. A couple more slides to summarize the results. And this is basically the same data that's on a previous slide. I don't need to go over that. Let's go forward to the next slide. And I certainly hope you're putting in some comments and questions into the chat as we wait. So one of the things we wanted to do was to extrapolate these results based on the case study in Kansas and Oklahoma across the US. And if you do that, the numbers get really big. We estimate that if you did employ grid enhancing technologies across the US, we would see about $5 billion in production cost savings, as well as 90 million tons of reduced carbon emissions. That's enough to offset all new car sales in the US in a calendar year. And as well as $1.5 billion of local benefits in terms of taxes and land lease revenues, significant jobs, hundreds of thousands of new short-term jobs, and even 20,000 long-term jobs. And the investment that would be required would be about $2.7 billion in the first year, with about $300 million of annual cost. So that's based on extrapolating the Kansas and Oklahoma sales of energy across the US to create the nationwide benefits we would estimate. I think I have one more slide, and then I'm going to wrap up my presentation. And this is important too, because we wanted to make sure that these results were reasonable, and we weren't making assumptions about the deployment of technologies beyond what one could actually expect to be implemented in the field and operated by the grid operator. So we worked very closely with the Southwest Power Pool grid operations staff to validate that these would be reasonable. And as you heard, we looked at these technologies. We deployed dynamic line ratings first in a solution set because it was simplest to model, actually. You'll see that the majority of the DLR installations are on 56 lines, primarily in the 138 and 161 kV voltage class, as you would expect, to help force that power to flow up on additional capacity that is actually available on the lines and not there and being phantom congestion as a result of static ratings. The second technology we deployed was the topology optimization in the bottom. You have to install the software once, you have to get it integrated into the EMS systems and operation systems. But once you have it there, you can use it. You can see that the majority of the line switching operations occurred, again, at the 138 kV voltage level. And the switching operations per day are not unreasonable and too much of a burden on the system. The last technology we deployed were advanced power flow controllers, such as smart wires. There may not seem to be a lot of applications here, but it's because all the low-hanging fruit was captured by the DLR and then the topology optimization. If we would have switched the order of using the technologies, you'd see a lot more advanced power flow controllers, obviously. We wanted to make sure that you understood that we thought this was reasonable, that these numbers have been shared with the grid operators as well as the project sponsors. I look forward to the conversation and appreciate your interest in this topic.
Thanks, Jay. That was fantastic. It's so much information to compress into such a short presentation. And again, the link to the full report is available. So be happy to take your questions on the full report. Rob Gramlich is going to provide some comments next, just on sort of broader implications on what's happening within the U.S. power grid, putting some of this report in context and drawing in the transatlantic perspective. Rob, over to you.
Great. Thanks, Jenny. Can you hear me all right?
Yes, we can.
Good. And thanks, Jenny, and thanks, Jay. Jay, of course, and I work together at Good Strategies and also support the Watt Coalition. I am based in the Washington, D.C. area, so greetings from Washington, and I work a lot with policymakers here at the national level on transmission policy. So I'm going to talk a little bit about what the U.S. Federal Energy Regulatory Commission is up to. FERC is the transmission regulator for the most of the country, as well as Congress and the new Biden-Harris administration. There is a lot happening in all three areas, as Jenny and Suzanne indicated. There's a lot of growing interest in grid enhancing technologies. In fact, that term was introduced by FERC last year as a result of our lengthy communications with the agency about what we were calling, I guess, just advanced transmission technologies, but they bundled them together and called them grid enhancing technologies and GETs. And the agency had a number of processes and discussions over the last couple of years with a workshop on grid enhancing technologies in which international lessons were considered. We had some lessons from the UK and Australia in particular, where the agency and stakeholders here were really trying to look around the world and see why it was that GETs were being deployed in some countries more than others. I think there was wide recognition among FERC staff and commissioners and stakeholders that the technology is really advanced and commercially available now. But what matters a lot now is the incentives. And so FERC, as an economic regulator, took on these initiatives to really evaluate the incentives more and to see whether something was wrong in the current incentives or whether something additional was needed. So after that process, and there was also, I should say, also a workshop on line ratings specifically, and a separate rulemaking on that. And then a proposed rule on incentives for a variety of transmission-related topics, including grid-enhancing technologies. And then just recently, the agency announced a special workshop on grid-enhancing technologies incentives, where the subject of the workshop will be our WATT proposal. We call it a shared savings incentive approach, which was our attempt to look at examples from the UK and Australia and apply it to our unique market structure here in the US. And so we're looking forward to that proceeding. And then FERC also has initiatives coming up on interconnection queues. Jay and Jenny mentioned how many wind and solar projects are stuck in our interconnection queues and our system to get connected to the grid, as well as transmission planning. I think the commission, under its new chairman, Richard Glick, is very interested in all these topics: grid enhancing technologies, interconnection queues, and transmission planning. So we're hopeful, and we expect to see significant activity in these areas. So that's FERC. I will just give my own prediction that I'm very optimistic we will see some action from FERC on incentives for grid enhancing technologies. I don't think the agency would be going through this whole process with a special focus and workshop on the topic if they didn't intend to move it forward. There's certainly enough keeping them busy that they likely wouldn't do that without that intent, but we'll see what comes out of the workshop. Let me move to Congress and the administration also here in Washington. There have been a number of reports coming out of Congress, as well as directives for the Department of Energy to study grid enhancing technologies. There was a dynamic line rating report. There was a letter from 13 of our senators to FERC saying, please take a look at grid enhancing technologies and incentives there. And that letter harkened back to a law that we have here passed in 2005, which was specifically about I'm reading now, directs the commission to encourage deployment of transmission technologies and other measures to increase the capacity and efficiency of existing transmission facilities and improve the operation of the transmission facility. So this is a law that we have passed in 2005. And of course, at that time, these technologies were not nearly so advanced, and the commission didn't really do anything with it at the time. So what we've said and what the senators said to FERC was, it's time now. The technologies are ready, so please review the incentives and make sure they're aligned so that utilities will deploy them. So that's, again, the process that's happening at FERC, but also with this encouragement from Congress. And then we have an administration, you may have noticed, the Biden-Harris administration, that is very interested in infrastructure and very interested specifically in transmission and clean energy. They have ambitious plans out there on transmission. We've not seen too many specifics. There's $100 billion for, quote unquote, the electric grid. That could mean a lot of things, but we have spoken with the Department of Energy in the White House, and we think they understand the opportunities of grid enhancing technologies. The administration is working with Congress on whether they do a bipartisan infrastructure bill or whether Democrats do something on their own. And I think all of the details will depend on what posture they're in, whether it's a bipartisan bill with Republicans or a Democratic only bill. So we're sort of waiting to see how those high level negotiations go before we know what the details will look like. And then I'll make a comment. The states are very important here in the US. There are a number of states in the central region that are pushing grid operators and utilities to deploy grid enhancing technologies. So that is also encouraging, another indication of the higher visibility that the issue has here. And we also talked to a number of grid planners, and we're hearing from a number of RTOs that they're taking a look at these technologies. I would note from my recent experience that some of the grid planners and operators that are in more densely populated parts of the country are looking more closely at grid enhancing technologies, because here in the Mid-Atlantic near DC on the East Coast, for example, it's very hard to think about new rights of way for transmission. So it's probably a little closer to Europe in that regard compared to Oklahoma or the middle of this country. But in the parts of the more densely populated areas, I think there's more of a concerted effort to look at grid enhancing technologies, because the opportunities for new rights of way and new transmission is more difficult. So I'm hopeful we'll see more international cooperation. Again, our policy initiatives here have been based in part on some lessons from Europe, and I'm sure this administration here, the Biden-Harris administration, is interested in international cooperation and sharing lessons back and forth. I can't speak for them, of course, but that's how they are operating in many ways. So anyway, that's the report from Washington. Jenny, I'll turn it back to you and look forward to any questions people may have in the Q&A.
Thanks a lot, Rob, for this interesting feature. Indeed, America is back. Maybe it was never out of the climate story, really, at least as many claim. Maybe not the government. Yeah. So now I'm very curious to hear what Oliver from the European Commission, Oliver Koch, Deputy Head of the unit, is going to say on this. We have with the clean energy package, the 70% target on the borders. That means that there's a minimum capacity that needs to be made available for markets. It's one of many challenges for transmission system operators in Europe. So it's interesting to understand Oliver's perspective on grid enhancing technologies. You heard the report, Oliver, you heard from Jay and also from Rob. What is the state of play in the US today, infrastructure investments and others? What is your perspective?
Thank you very much, Susanne, and to the organizers. I'm extremely excited to be invited, and of course also about the developments in the US. The model of the whole liberalization, the idea that we can use markets for something like grid-bound product like electricity is something that, of course, very much came from the US. What I think we are experimenting with in Europe is not so much the Green Deal implementation. Yes, that's also an experiment. I mean, going really to very high shares of renewables. We have one element of the experiment, and that is a cross-country grid project. And that's essentially it's market coupling, the idea to really combine 27 independent countries into a single grid with combined grid operation, and that's in a way a crazy process. It's unique in the world, and I will talk a bit about our learnings from this. Essentially, what I will say is that there are three things I would stress today. So first, we are in an all hands on deck situation. This is really something where things will change, and we need to activate everything we have, including technology. The second one is also, if you ask me and us and our team, I think even the energy experts in Europe now, they will tell you interconnection is a no-brainer. Aggregation is a no-brainer. And we see it in all regions of the world that this comes now to the minds. In a variable system, it's just the cheapest way to deal with it if you have the possibility to aggregate over larger regions, to exchange over larger regions, the connection between the energy transition and more aggregation, system integration, and larger regions of exchange of electricity is just so compelling that I would say this is really a constant of the energy transition. So aggregation is a non-brainer. But third point, interconnection is not about technology first and foremost, and that's a kind of a bitter tone maybe to you today. It's very important, and we're excited about new technology. But if we think interconnection, we must think political. The barriers to combining and aggregation are not technological, they are political. And that applies, I feel, in all regions of the world, be it China, be it Texas, be it Europe. And to really promote interconnection, to turn it into something positive, we need to address and understand the political consequences of interconnection. What changes for the players? What are the distributive effects? Because there are such effects. And without doing this, the best line ratings and the best technological innovations would remain without effects. And that's indeed one of the main learnings of Europe. So please take into account the political side of it. So that's the three things. First, all hands on deck situation. I was with my son actually on a tall ship, you know, these old sailboats. And there was a situation when there was this old order, all hands on deck. There was a storm coming, so everybody was needed on deck. And I think that's very much a situation we feel, at least in our little energy ministry here in Brussels, where essentially everybody is working on one of the over 60 legislative proposals we are working on to implement this European Green Deal, which last year was only a commitment with some strategies. And this year, 14th of July, interestingly, in a few weeks, we will come with a massive set of new legislation implementing this. So this creates a tremendous expectation in terms of decarbonization. The pathway has been set, 80% electricity in 2050, and we are far away. Susanne has mentioned the decarbonization targets. I could mention, of course, you have all maybe seen the IEA report. It's breathtaking. We've seen a stream of judgments recently, not only the German highest constitutional court, a Dutch court ordering Shell to revise its fossil policy, the same in Australia. So we really are in a times of change, all hands on deck. And that will be something that will help you and help your projects. Because, and that's the second point, aggregation is a non-brainer. And that is really one of the main learnings of our experience. We had a good starting position because we had a quite a large and synchronized grid. It used to be the largest electricity grid in the world. Using this is a huge asset for going to wind and going to solar. And that is something that has been acknowledged and is realized now. And we are working desperately now to finance new interconnectors, new distribution grids. We are investing really billions into this. So the hardware is important and has been increased, especially in regions which are a bit remote. In Europe, that's Spain, for instance, the peninsula there, or other regions, the Baltics. We invest into infrastructure there. That is one side of the coin. We invest into technology. We have a Horizon Europe technology innovation program with over more than 10 billion euros, and the recovery money, to a large extent, 37% go to climate projects. In a large extent, this is also pilot projects, research, and grid-related projects. So this is part of our push, technology, hardware. And we honestly, in the years, we have been dealing with this relatively steep increase of renewables in some areas. more than 50% of electricity supply already. We have not seen anybody putting into question the key importance of our cross-border grid, which is really a unique concept. Again, liberalized markets you find in the whole world. You don't find cross-border markets with 27 sovereign member states agreeing to outsource their grids and also their autonomy over how much capacity can I give at the borders, how much electricity is flowing in and out, that have outsourced this to central bodies, to majority decision making. This is quite a unique project in the world. And I think I'm always asking my US colleagues, why don't you go there? And I think the reason is why the US has also some hesitations, and why in China, where we have, I think, an IEA study showing that you could have a 15% of operational cost reduction, 63 billion euros a year. If you integrate the grids, you could have a price decrease by 10%. It's an IEA study from a year, I think, on the China power system transformation. And I guess you could find other areas in the world where this will be applied. And the question is indeed, why the hell are we not doing this? Why is it not happening? It is a no-brainer for I mean, just engineers and if you come from a physical side of the system. But the answer is, and that's in this forum where I also talk to engineers, don't underestimate the politics. And the politics are massive. And the fact that Susanne speaks about a 70% rule, in a way is a bit astonishing, because we are in Europe in an internal market. We're supposed to exchange without any internal borders our goods. Electricity is a good. So why is it that, as Susanne has said, effectively, all the nice infrastructure, we have the biggest grids, fantastic power cables, they are used only to 10, 20% at some borders for exchanges with the neighbors. That has a reason. And the reason is that grid integration creates distributive effects and winners and losers. If you're an electricity producer in a high price area, you do not fight for a connection to a low price area to your neighboring state. If you're an incumbent, not very efficient in this country, but can still benefit from higher prices, you will not be very interested in using the best technology to increase cross-border flows. You will rather ask for a subsidy to erect your own renewables windmill, even if there's less sun in certain states and less wind, maybe. So there is really a problem with opening markets. And I understand from my conversations, even with Chinese colleagues, even in a central planning, if you wish, communist country, there is a strong incentive not to connect to neighbors because it reshuffles the game. It can be good for some, but often, especially if you're a national incumbent, you may not have an interest to connect to get imports. Everybody likes exports, nobody likes imports. So this is a problem we need to tackle. We did this indeed with the clean energy package. The whole set of voluntary solutions we had over 20 years, they just did not work. And we saw that barriers to cross-border exchanges were massive, and the incentives not to open the borders still remain high. And that's something indeed why we have a rule now. It's this famous 70% rule, surprisingly, but it is there, that we have gradually until 2025 to open the borders to cross-border trades, only if the price is cheaper to let them in, which is not happening now, which is a bit surprising in a system where this should happen. We have European-wide market coupling. Almost all countries are in a system where you have on a central computer all the bids and offers in Europe, and electricity is sent where it's most needed. And that is an incredibly efficient system. And I personally think we could very well export it. US would be a very good candidate in a way, because at least you have a relatively homogeneous political system, which may be more difficult than in Middle East or other fragmented countries. But also there, if I talk to the colleagues, why PJM and others are not keen and why Texas is isolated. Of course, you know, there's a regulatory reason for autonomy in rules. And we've seen that these reasons are quite strong. So my plea with all interest, and I'm listening very carefully, we will read all your reports, take into account the policy angle. We will have a tremendous change. All hands on decks are needed. Interconnection is absolutely necessary, but it will not materialize if we don't at the same time think about how can we incentivize integration, not only have the technologies, but move voluntarily, but maybe also with legislation, the states, the countries to actually use this potential for a more efficient electricity system. Thank you very much.
Thanks a lot, Oliver. I think that was really interesting to hear that you're saying it's not a technological issue, it's a political issue somehow, yeah. And so it would be interesting maybe for a brief question back to you. You heard the numbers presented by Jay on this battle study. I said also in the beginning that we will do another study in Europe answering one of the questions in the chat with Consentech, showing the combined benefit of the available new technologies. Yeah. So what can you do in Brussels to get this pushed? I'm thinking of TENI, of some of the legislation that's out there. Yeah. And of course, we need to avoid the research and development silo that sometimes exists, especially for those technologies that are mature. Oliver, a brief question back.
Yes, no, I'm fine. If I can answer directly already now. I think indeed we had a problem. We still have a problem of fragmented research. I think, to be honest, your previous employer, the TSO organizations, they did already a lot. We have since many years a project to give infrastructure money not only to railways, but quite some money to electricity grids in the billions. I would personally think, and I've been working, and 230 colleagues of DG Energy have worked on the recovery plans. There is a lot in for distribution grids, for TSOs, grid integration. We have very good pilot projects. So I understand your criticism in a way. It's true, we had national R&D policies very much, and grid development policies were certainly very national. But this interconnection cross-border effect is developing fast. And of course, all the digitalization aspects. And my hope would indeed be, I mean, sit together with US colleagues and learn from each other in these aspects. When I say the barriers are also political, don't get me wrong, we need to have more efficient grids. I mean, Giles will speak in a minute about how to get 300 gigawatt of offshore wind onshore. We need grids for that, and very efficient grids. So we are throwing a lot of money at it, believe me, and I'm just encouraging everybody to cooperate closely to use all this potential. Thanks.
Thanks a lot. And I think, Jenny, there was also a question for Jay before we continue.
Yeah, exactly. So Jay, could you answer a question regarding how in the study did we model the energy system and the benefits of the technologies?
Yeah, so what we did, we modeled the actual power flows for the entire SPP system and beyond, right? One of the things to keep in mind is we basically fixed the transactions on the ties between SPP and adjacent regions, which is one of the reasons we didn't see significant benefits, I think, of GETS in the Kansas area, because Kansas City is the major load center. It's right up against the Mid-Continent ISO as well as the associated electric cooperative systems. In this simulation, we only did a lot of power flow analysis, but we constrained the net exports from SPPs. So even though we could integrate more renewables into the SPP network, we didn't allow them to be exported off system in these simulations. So in that respect, it was a pretty conservative power flow analysis.
Great, thanks, Jay. All right, Suzanne, let's hear from the rest of the panelists.
Absolutely. So now we have John Fitzgerald, the CEO of Supernode. Now we enter the space of wind. John, because Supernode focuses on offshore wind. John, please.
Okay,
what's your answer? And I would like to ask all next speakers to really respect the 7 minutes that we have in order to have some time for the discussion.
Thank you. Can you hear me? Can everyone hear me? Yep. Okay. Good afternoon. Thank you so much. And well done, Jay. I think I really envy your certainty, and it's great work that's been done. And in just following on from Oliver, I totally agree that the political barriers are there. And I'm reminded of John Milton, who said that sometimes it's better to rule in hell than serve in heaven. and there's a bit of that goes on too. So I'm focused beyond 2030, really looking at it takes so long to develop new grids. I'm focused beyond 2030 out to 2050, and I see a need for a lot of new grids. Next slide, please. And really, you have to ask yourself, what do we need? And it's trying to look ahead. It takes so long to do this, and based on a lot of benchmarking and the European, the 1.5 new tech scenario, and the amount of increase in electrification and so on, we see a demand over an increase of 2 to 3 times by 2050. Now that's a huge amount of grid, and there's two things going on that we see. And one is we're turning off all the carbon machines and we're turning up the renewables. So Giles will talk later about the offshore piece, I'm sure, but there's 450 gigawatts at least of offshore wind. There is more again of onshore wind, and about 800 gigawatts of new solar required. And the best resources and the best load factors are to be found at the peripheries. And that brings together two things: gigawatts remote from load centers that are all going to be at the center. So you got your kilometers and your gigawatts. And that's going to put a lot more demands in terms of the transmission, in terms of that being a bottleneck or a constraint on our ability to decarbonize. And the most efficient way to move power is with transmission lines. And we know that, and the question is will we be able to get enough of them? Now, we know there's low public acceptance. In the past, I've developed overhead infrastructure. It's very challenging, particularly in Europe. And also, if you look at the quantity of transmission that's required, you start worrying about supply chains. So copper, can we continue to extract it and get those level of grids? And it's for those reasons that it's nice to focus on 2030. But beyond 2030, there's a lot of ambiguity about the type of grids we're going to need. Like people talk about the system of systems and so on and so on, but how much transmission are we going to need? And there's a lot of ambiguity about that. And that's understandable, but we can't ignore it, because there's no point charging towards 2030 and getting stuck, because it takes a long time to develop the kind of grids that I believe we're going to need. Next slide, please. So Europe is not unique, and mine is a European perspective, but there are other major commercial blocks, and they've got the same challenges, like in China, where a huge amount of the demand is on their east coast, and their best renewables and generation is in the north and northwest. And they've done an incredible project there, where they've built a 3,324 kilometer line. Now, this isn't just any line; it's the single biggest piece of transmission infrastructure in the world. It's 1100 kV, it's 12 gigawatts, it's a DC overhead line. The towers are absolutely enormous. And I just bring your attention, this is about 2 years in operation now, it's the second year of operation. These are people on one of the poles doing a bit of maintenance. So if you look to one of the poles, there's a plus and a minus. This represents 40,000 gigawatt kilometers. So that's a lot more transmission capacity to move power from A to B than Europe has built in many years. And it's just incredible infrastructure, and it'll work in China. I don't think it'll work in Europe, and certainly not in many parts of America. But that's the type of infrastructure that's required to decarbonize, to do deep decarbonization. Next slide, please. So I've got 4 significant reference points here, and 2 of them are pros and 2 of them are cons. And if I focus on the left, the Florence School of Regulation, a venerable body, produced a report late last year where no less than former Andreas Piebalgs and a former head of DG Energy came up with a report supported by the Florence School of Regulation and the people behind them, they're experts. And they said that apart from energy efficiency, which is really, really important, the most important and immediate priority for the European Union and the whole continent of Europe in ensuring a cost-effective decarbonization of its energy system must be to identify and eliminate infrastructure and other bottlenecks. So I think generation technology, it's fantastic. The price of wind, the technology, the solar, it's just been incredible. And they're really pointing towards the big bottleneck's going to be our ability to move it from where we can generate it to where we can consume it. The second point is a quote, just back a slide, please. Yeah, from Acer in 2019, where they said that a recurring theme is that almost half the PCIs which are projects of common interest in Europe, have been shifted. So their dates of delivery have been delayed because of holdups in the public planning process due to issues with public acceptability and so on. So there's a real issue in Europe to develop the kind of infrastructure we need. Now, I'm a developer of technology and not grid enabling technology for 2030, but for beyond 2030. And we're working on superconductivity, which needs a smaller right of way. And there's been a lot of work done, and there's some great projects that the European Union have sponsored under the Horizon Best Paths, where they come up with the largest superconducting DC line in the world, which was a 320 kV 8 gigawatt circuit, which is the type of power you need to move in a future where electricity takes over transport and heating pumping, where you see a threefold increase in the amount of electricity. You're going to need a lot more grids. So tweaking it will help us get to 2030 and grid enabling technology. But beyond that, we're going to need lots of new grids. And I think HVDC cables have been seen by the SETIR report, which is the clean energy transition. The first report was done last year, and it has recognized that there are technologies that can get us there. So I'll go to the next slide, please. And I think just a little bit about superconductivity first, because some people think it's a strange phenomena that's in a lab somewhere. This is something that's been operational with progressive utilities in Chicago, in Germany, and in Korea, where they've actually got it in use in urban environments. But it's got four very interesting attributes. Firstly, it's no resistance, so there are no losses, so it's really efficient. Secondly, it's high power density, so you can fit a lot of power in a very small space, which is very useful when wayleaves are a challenge and building infrastructure is a challenge. And finally, the cost can be lower if the scale is high enough. So it mightn't make sense to move a megawatt 100 kilometers, but it might make sense to move a gigawatt 100 kilometers. So it's just a question of scale. And the scales we're moving to, we think the superconductivity is now becoming a real option for operators and developers to move their power from A to B and to get it done quicker and to accelerate and enable the transition. Next slide, please. This is a view of the future, and I would say there are probably more holes in this than in Swiss cheese, because we're actually looking out to 2050 with the scenarios as espoused by the European Commission and others, the IEA and others, and we're looking at them and we're saying, how can this be met and how could you dispatch such a system? So we looked at a winter afternoon in Europe, typical wind dispatch, low solar, high wind in the North Sea, and we split Europe into 5 regions. So we had Ireland and the UK, the Nordic region, Central Europe, the Iberian Peninsula, and then the southeast of Europe. And we split it because we didn't want it to be too granular, because there's a lot of uncertainty here. And we looked at 2 scenarios, one where we continue with a nationalistic approach to grids with interconnection. And you can see the transfers are absolutely, they're significant. So 13 gigawatts into the Iberian Peninsula, 13 gigawatts into Central Europe, and then to the larger amounts into Central Europe from Scandinavia and down into southeast of Europe. And this is a European vision, so there's very little external interconnection here. This is very much a European-centric study. And you can see that you need about 3,200 gigawatts of generation and storage. On the right is a pan-European grid, which is truly a European grid, not interconnection, the national grids. It's a European approach. And you can see larger flows. So there's a totally unconstrained dispatch where there's hundreds of gigawatts transferring. That's not credible or realistic. This is a pan-European approach where grid is a constraint, but not to the same extent as under a business as usual approach. And you can see a saving of 15% with the pooled aggregate. So back to Oliver's point about being a no-brainer to build interconnection, it's a no-brainer to build a lot more grid. And I believe that the arguments are becoming more and more compelling. And the real thing here is the amount of money you save by having to build less renewables to meet demand and saving money by doing it. So I put a health warning on this because it's a view of 2050, which is so far away. But I believe we have to take a view of the future to plot a way there. And while it will be uncertain and there will be changes, it's important to have it. So this is what we're using And this is why we're developing technology for that eventuality. Thank you. Happy to take any questions.
Thanks a lot.
I've
Thanks a lot, John. And in the interest of time, let's right ahead go, because then we have a little bit of time left at the end. Michael Jesberger, CTO from Transnet BW, and I think one of the most exposed, or the most exposed TSO with the nuclear phase out next year in Germany, the lack of Südlink. What are you doing, Michael? How do you see this report? What does it mean to you, Transnet?
Yeah. Thank you very much, Susanne, for the invitation, for the warm welcome, and for the introduction. The energy transition in Germany has started 10 years ago with a target set by the German government saying that in the year 2050, 80% of the electrical energy consumed needs to be generated by renewable resources. Meanwhile, the target has been reinforced, and we have to be faster. So it's expected that the target needs to be achieved in 2036 already. When I read the study, I have detected a lot of similarities with our approach, whereas we have not asked the question how much renewables can we integrate in the grid. We have asked the question, what grid do we need to make the target happen? And I think it's with regard to the calculations made and the models, it can be compared, but the beginning was different. When we have started 10 years ago, we knew a couple of things. We knew that at least after Fukushima, that the nuclear phase out will be finalized in 2020. At that point of time, in 2011, we knew already that the coal-fired power stations were under discussion. We also knew that our grid, which has been erected in the 70s and 80s, is an old-timer, well maintained, but with regard to the ratings and the topology, not able to meet the demand of the future. And we also knew that, and this I think is known in the entire grid community, that we need to communicate a lot with society and especially with politics, that the grid is not meeting the expectations and the needs of the future in terms of making an energy transition happen. And especially with the politicians, the very intense discussion has started. Politicians, they are used to develop and influence political laws and regulations. But here we are dealing with physical laws and physical and technical laws, which cannot be influenced by politicians. They are defined by nature. And this makes it quite interesting in the dialogue that on the one side, natural laws and regulations need to be considered, because at the end of the day, we talk about a technical project when we talk about the decarbonization of Europe. And we also knew that we are connected with neighbors, with electrical neighbors, with political neighbors who have different targets. So in this synchronous area, with a high quality of supply, we also have to talk with our neighbors about the targets we have received and the grid measures we have to take. So this was clear to us. When you look to the map, you can see the political borders of Germany. And in the past, we had our big power generation units decentralized close to the huge consumption areas. And with the energy transition, nuclear power stations will be shut down, predominantly located in the southern part of Germany, and including the coal-fired power stations. And the wind is by definition in the northern part. So from a transmission perspective, we are building centrally a huge power station up north, and we have to bring down south the energy comparable with the Midwest, where you have the wind areas in the US. And you need to transmit this energy to the eastern and to the western part of the country. So, and our grid, of course, was not designed for this task. And that's the reason why we have to optimize, why we have to reinforce, and why we still have to expand with AC technology, but also with DC technology, our grid. In parallel, we were thinking about the higher utilization rate of the existing networks. On our N-1 criteria, we had discussions. We had discussion about load flow regulating network elements, and of course about new operating concepts in connection with new operating resources. In the table, you can see the numbers that we have scheduled in the year in the National Grid Development Plan for offshore wind. This is only an example: 17 gigawatt until 2030 offshore, 59 gigawatt onshore wind. As per today, we have around 13 gigawatt offshore already connected to the grid, and around 45 gigawatt onshore already connected to the grid. And the plan is, and this shows the increasing ambition, that in the year 2035, we will see 35 gigawatt offshore and 68 gigawatt onshore, which also needs to be integrated in the grid. The Green Deal numbers are not yet contained, and today we are talking about 300 gigawatt in the North Sea only. Next slide, please. When it comes to planning, and I just said that we are connected with our electrical neighbors. Of course, we do some European grid planning via NSOE, which is the TSO Association of Europe. And we need to understand the impact on the installment of renewable resources and shutting down process of coal-fired power station or other conventional plants on the load flows on our net transfer capacities between the various control areas. Once we understand the European planning, which we do every second year, we perform a national planning. In the middle, you see the German map again. And it's not a surprise that most of the measures which are defined newly are going north-south. And then on the third map on the right-hand side, this is then the regional planning, where we are defining a little bit more in detail the local measures, which mean optimization of the existing grid, reinforcement of the existing grid, or totally new overhead lines or cable connections. Next slide, please. This is a map of our control area, and all these boxes you see are new measures for reactive power compensation, for load flow control, for stability improvement or reinforcement. And we are also planning a grid booster, which is a huge storage device which help us as well to increase the existing, or to make use of the existing capacity of the grid on a higher level. So a lot of things we need to do as a consequence of the installment of more renewables, more wind, more photovoltaic in the southern part of Germany, where we have more sun than in the north, but also let's say the farewell of the old reliable coal-fired power station and nuclear power stations. Next and last slide. This is a map from our scenario B 2025, where we look into the year 2030, and the boxes are already confirmed so-called ad hoc measures. In this case, phase shifting transformers, where we already steer the load in our existing grid to make better use of the existing capacity, which helps us to reduce also the congestions which we have on a very high level, because grid expansion, we learned that before, takes a while. The renewables are almost on time. The nuclears, they go on time. Grid expansion is delayed. This is generating congestions in the grid in the middle part of the country, and therefore we need to shift the load flows accordingly. Since 5 years, we have dynamic line rating in operation up to a high extent, already level 2. This will be further developed to level 3 and 4, and we have the ambition that we do that online. What does online mean? That we follow the temperature on a 2-hour basis to increase the thermal current accordingly, also for higher utilization of the existing capacity. So innovation in the system, new technologies in the system are a must. It will not avoid new lines. It will not avoid new strong DC connections, which we need, most probably all over Europe in the future. But load steering elements will help us also in the future even more to increase the utilization rate of the grid and of each and every circuit. So far, my short trip to the German energy transition. So thank you very much for listening.
Thanks a lot, Michael, for this explanation on the technologies that Transnet is using, and there will be much more to come, as we know from the interactions with you. Now we have Giles, last but not least, to present your view. Wind Europe has also published a paper on optimizing the power networks. Are very keen to have your perspective.
Thank you very much, Susanna, and thank you to Jay and our American friends for this really useful study. Wind is now 16% of all the electricity we consume in Europe. Solar PV is another 6%. And both of us, wind and solar, are passionate supporters of grid optimizing and grid enhancing technologies. We are actively pushing them with our respective members, with the TSOs, whether it's advanced monitoring, including DLR, advanced power flow control, grid forming converters, HVDC, all of it matters to us. Oliver has mentioned the very ambitious EU target that there should be 300 gigawatts of offshore wind by 2050. An even more ambitious target actually is the onshore wind expansion target, which is 1,000 gigawatts by 2050, up from 165 gigawatts in the EU today. So we need all of these grid optimizing technologies to integrate both our offshore and our onshore wind. And the EU wants wind to be 1/2 of all the electricity we consume in Europe by 2050. One of our very large members, Ørsted, the Danish utility, did a study last year with Aachen University in Germany, looking only at the German market and the potential for grid optimizing technologies to increase and support the integration of offshore renewables in the North Sea. They looked only at DLR, phase shifting transformers, and HVDC. And the conclusions of this study were that the deployment of those three technologies alone would allow an additional 3 gigawatts of offshore wind to be integrated into the energy system in Germany, 3 gigawatts more than Germany's current government target, which is 20 gigawatts of offshore wind by 2030. So that's plus 15% in the total offshore wind integration capability, just from the deployment in Germany of DLR, phase shifting transformers, and HVDC. The study also showed that DLR alone could reduce the congestion management costs by reducing redispatch by 6.8 terawatt hours a year in Germany, and it could reduce renewables curtailment in Germany by 2.5 terawatt hours a year. So it's a significant contribution that these technologies can make to supporting the integration of variable renewables. Now, I agree with you, Oliver, that this is not about technology. The technology is available. It's about other things. You've singled out the political cross-border factors, and you're absolutely right. But I think there's another non-technology factor which is at play here, which is investment incentives. And crucially, we believe that with the revenue model that the TSOs in Europe have today, which is based very much on reimbursement for CapEx investments and only for CapEx investments, that there are insufficient incentives in place for TSOs to invest in grid optimizing and grid enhancing technologies. We really believe that the TSOs should be allowed to move away from CapEx only revenue models to TOTEX revenue models. And we need to incentivize them to make these TOTEX saving investments that the grid optimizing, grid enhancing technologies represent. We believe also that it's important to revisit the cost benefit analysis methodologies so that they factor in both the short-term and the long-term benefits of grid optimization solutions. Our next recommendation is that, of course, we need flexible system planning that allows us, as we go along, to integrate new needs that we identify in the operation of our energy systems and new technology developments. Third recommendation, very important, that we apply smart grid indicators that address planning, system and market operations, asset management and innovations. And ideally, those smart grid indicators should come with some very clear benchmarks. And I'd like to end with a thought to you, Oliver, in the European Commission. You and I have seen, and others have seen on the European side, what a useful study this is that Brattle have carried out for the US context. It would be really helpful, we think, Oliver, if the European Commission could carry out perhaps a similar study, but certainly a study that defines the grid optimizing technologies for Europe and quantifies or attempts to quantify the benefits for the EU that investment in grid optimizing technologies could bring us in terms of accelerated deployment and integration of renewables, in terms of the management of congestion and redispatch costs, and in terms of really enabling us to understand the interconnection investment needs across our European grid. We think that such a study would probably show us that the TSOs should update their CBA methodologies to factor grid optimization into their long and short-term planning. And we think also that such a study should consider benchmarks for smart grid monitoring. If I could conclude by continuing your sailing metaphor, Oliver, we believe that such a study carried out, supported, backed by the European Commission, could give us the sort of navigation chart that you, the great ship of state that are the European Commission, and the rest of us that are nobly trying to keep up with you in the smaller vessels, a navigation chart that could help us all find our way through these challenging seas that are the energy transition. Thank you.
Thanks a lot, Giles. I think this was a great proposal, and Oliver, it could be interesting to see you react to this proposal. Have the European Commission do a similar study like Brattle did for Europe and have a navigation chart for the vessel that you have described before? What's your answer, Oliver?
I think, Giles, you don't have to convince me. I mean, I shouldn't say it because it's again data protection, but the first thing I did with John's presentation, I took a screenshot and will use it in my next presentation to argue how interconnection can save generation, because that's our mantra. And indeed, we are looking for more studies and facts. And I mean, we do have them. And I think there is something ongoing, but I mean, I'm very happy. For us, it would be very good in our daily advocacy to come from also the national thinking, and that's what we just seen. I mean, for the US colleagues, you always see national. We have still 43 grid operators who do their national planning in this whole discussion. So we don't have an ISO, anybody who really has the overview. We are trying to get there with this integrated planning and with some grid coordination, but yes, these studies is what we need because we want to spread the message. So certainly it's a good idea. We will look at it, and I will sit with my colleagues and think about. I mean, we need these studies. It's an invitation to you also. If you want to market with us the benefits of the internal market, and entre nous, I've just discussed it with Giles for the offshore grid. Our vision for the 300 gigawatt offshore grid is a grid where electricity flows where it's needed, and where we don't have 300 radial connections to 300 coasts, which makes no sense. But to get the investors there, to get the member states there, it's quite some effort, and also there. Any figure, I mean, also we have some studies on the benefits of the offshore grid, but this is exactly what we need. Facts. Sit with the politicians, ask them, you need to do this now. Why don't you choose the cheapest solution for your citizens who will have to pay a bit for the Green Deal? So that's my hope. So yes, by all means, any good study is welcome, and we will certainly think and sit with you what we can do with our limited study money.
Excellent. I have one question to Michael Jesberger. Michael, in your very interesting presentation, you named technologies, and several of those that are precisely in the Brattle report, like the dynamic line rating, different types, like superconductors presented by John, or also FACTS devices different from PST, have not been mentioned by you. So where do you see the space for those, having looked at the Brattle study?
Yeah, superconductors. Can you hear me? Okay, on the AC side, they are in use. So there are a couple of projects. I think it's around 11 in Germany on the 400 kV side. Then we are using for the first time 500 kV DC XLPE cable for 700 kilometer DC link from north to south. No surprise about that one. 500 kV DC links. We have not, we have thought, of course, and we have calculated superconductor, but in this voltage level and this current class, you don't find the right assets on the substation side to switch these huge currents, so this is not yet available in the market. On the other side, it's quite costly to keep them down on, I think, minus 200 degrees centigrade. So that's, I would say, technically not feasible, and economically also not. What we are going to build is a big storage device, 200 megawatt hours, as a grid booster, which is a curative element. So we are increasing the current on our circuits above N-1 level. And we are using with fast protection schemes then the storage for fast load shedding either, or injection of energy onto the electrical failure. Sounds very technical now, so sorry for that. But this brings innovation along, that you have to talk about technology, and then immediately you are in the detail. Phase shifting transformers, STATCOMs, so static VAR compensators, a lot of power electronics we will see in the grid, series compensation, so all things which we haven't had in the past, where we still had the rotating masses, the big ones, where voltage regulation was not that big issue as it is today, and will become even more important in the future, that we keep the grid stable, and that's what we are committed to.
Thank you, Michael. That's a great wrap up. You raised a lot of the issues around the technological challenges. And I think what we've heard today is from all these panelists, technological and political challenges. Thanks again for all the panelists' time today. Unfortunately, we're out of time. I wish there'd been more time for Q&A, but thank you for your engagement to raise awareness of the work that Watt and Current are doing. And we look forward to working with everybody here to solve the issues that Giles and others raised. And Hope everybody has a good rest of your day. Thank you for joining.
Thank you very much.
Thank you. Bye-bye.
Thanks a lot.
Thank you.
Take care.